Hello everyone. In this video, we are going to discuss about the need for process synchronization. So before we move into the need for process synchronization, we must first discuss about two different kinds of processes. One, what is an independent process, and two, what is a cooperating process. Now coming to what is meant by an, an independent process. Now, when will we call a process as an independent process? If I have two processes, say P1, P2. P1's execution does not affect P2 and P2's execution is not affected by P1 when they are running concurrently, then I will call P1 and P2 as independent process. Therefore, from that, now I define what P1 what an independent process is. If the execution of a process is not affected or it does not affect the execution of another process, then I call the process as an independent process. Suppose the execution of a process affects or it gets affected by the execution of another process, then I will call the process as a cooperating process. So let me once again refresh. I have two processes, P1, P2. Assume both are going to execute concurrently. If P1's execution does not affect P2's execution, okay, and similarly P2's execution does not affect P1's execution, then I will call P1 and P2 as independent processes. The other way around, I have two processes P1 and P2. If P1's execution affects P2 and P2's execution affects P1, then I will call P1 and P2 as cooperating processes. Hope the definition of independent and cooperating process is clear. Now with this, let's now move to two different kinds of cooperating processes, namely producer process and consumer process. With that, we are going to discuss what is meant by process synchronization and what is the need for process synchronization. Now coming to the first process, that is the producer process. Now producer process is a process which is responsible for producing items, and consumer process will be a process which is responsible for consuming the items produced by the producer. Now look at the code for the producer process. The producer process is responsible for producing an item in a variable called as next produced. So I'm going to have a buffer, okay, with some size. Let me say 5. So I have 5 locations in the buffer. Producer is responsible for depositing an item in the buffer, and consumer is responsible for consuming the item deposited by the producer from the buffer. So what the producer will do is, as it deposits item in the buffer, it will keep incrementing the variable counter. Similarly, as the consumer consumes, the consumer will keep decrementing the counter. Now look at the code thoroughly, if you'll be able to understand how it is done. So when will the producer not do anything? The producer will not do anything when the buffer is full. If the buffer is full, that is, I have some value in the buffer and all the locations in the buffer are occupied, then that means the buffer is full. Whenever the buffer is full, the producer should not produce. Similarly, whenever the buffer is empty, okay, the consumer should not consume. So while counter is equal to the buffer size, do nothing. Similarly, for the consumer, while counter is 0, that is buffer is empty, do nothing. Now, from the variable next produced, where the item is stored, it is put into the buffer. For the producer, we have a index pointer in. Similarly, for the consumer, we have an index pointer out. So whenever I deposit an item in the buffer by the producer, I have to increment in, saying in equal to in plus 1 mod buffer size. I do this mod buffer size only for the simple reason that once I reach the end of the buffer, if I want to continue depositing items in the buffer when the buffer becomes empty, I consider this buffer which is implemented as an array in the form of a circular array. And that is the reason why I say mod buffer size. So once an item is deposited and once in is incremented, I increment the value of counter. Similarly, with respect to the consumer, whenever the buffer is empty, the consumer will not consume. And from the buffer indicated by the out pointer, the item from the buffer is stored in a variable called next consumed. So whenever you consume an item, I increment the out pointer, which is an index variable for the consumer, in a very similar manner like how I do for in. So it out equal to out plus 1 mod buffer size. And then I decrement the value of the counter once the item is consumed. So these two processes, producer and consumer, we assume that they are going to execute concurrently. Now with this example, we are going to understand how synchronization is necessary between producer and consumer. See, the common variable which is being shared by the producer and the consumer is the variable counter. So what happens is whenever the producer is incrementing counter, it must make sure that consumer is not decrementing the counter. That is, the producer process and the consumer process must not be executing counter plus plus and counter minus minus at the same time. Why? Now we will see. The reason is shown here. See, I am going to implement counter plus plus in this manner and counter minus minus is implemented in this manner. So what is being done? Whenever you're saying counter plus plus, that means I'm incrementing the counter by 1. So I store the value of counter in a register. I increment the value of the register by 1. And then again, I store the value of the register in the variable counter. Same goes with the statement counter minus minus with respect to another register. So what happens is, let's assume counter value is currently 5, initially 5. Okay, so now what happens if both are going to execute at the same time, that is the producer and the consumer, then the first statement, that is the producer will execute register 1 equal to counter. So register 1 will be 5 because we assumed counter is 5 initially. Then producer executes register 1 equal to register 1 plus 1. So register 1 becomes 5 plus 1, 6. Now let's say, since producer and consumer are going to execute concurrently, let's say consumer executes register 2 equal to counter. So register 2, according to the consumer process, counter is 5, right? So register 2 is now 5. Now consumer executes register 2 equal to register 2 minus 1, which means register 2 will be 4. So according to producer, register 1 is 6 and according to consumer, register 2 is 4. Now comes the point where the third statement for both consumer and producer are executed. Now the value of the register 1 and the value of the register 2 will get stored back in counter. What is the value of register 1? 6. What is the value of register 2? 4. So according to the producer, counter will be 6. According to the consumer, counter will be 4. But this is contradicting. Why? Because counter is a single variable. We cannot have two different values for counter because two different processes are using them. So this is where the problem arises. I am having either duplication of data or loss of data. And this condition is called as the race condition. Race condition will occur whenever two processes executing at the same time, they try to make changes to the same shared data at the same time. We get a phenomenon called as race condition. So for two processes to execute without any problem, we must make sure that we prevent this race condition, and prevention of race condition only is the basis of process synchronization. So the need for process synchronization is to prevent race condition. I hope this was very clear to you. Thank you.